Design analysis of outcomes lab, experiment number 9. In this lab, I actually asked to implement branch and mode technique using. Sorry, yeah, in this lab, we actually asked to implement the branch and mode technique in 0 1 abstract problem. Go to the code. Like, like, like first, I'll show you the output. So, like, like this is a sample test case I use. Total weight is 10. Answer should be okay, 245 because yeah, here instead of yeah, the answer should be 245. The only difference between this test case and this is here I took 4 instead of 5. That's why it's 245. So now I'll go to the code. So here I have my own custom container called item with float and weight. Then I have the node for each node in the tree. And here I have my own comparator for sorting. I have the bound function here to get the upper bound. Here I have the knapsack function. First I sort all the values based on their uh, I sort all the values based on the price per weight ratio. Then I initialize a queue. I have two nodes, U for the uh, U for the uh, uh, U for the U for the node of the queue, and then B for the current node. So first I initialize the level of U and the profit of U to -1 and 0. Then I push U to the queue, and I have a variable called max profit is equal to 0 here. Until the queue is empty, what I do is I first take the top of the queue, that is the front of the queue, assign it to U, and I pop that. And if it's uh, the first node, then I assign the current level as 0. If it's the last node, then I continue. So if it's not the last node, then the current level will be the uh, the the current level will be the level of U plus 1. Here I take the current levels weight and I add the in this case I assign the current levels weight uh, uh, assign the current levels weight to the sum of the uh, uh, with the sum of the value I got from the U node and the value of the current level. Uh, and here I'll be doing it for both weight and profit. Here I'm going to check if uh, if here I'm going to check if this weight is less than W. If in case it is less than W, then means eta be the max profit. If it's not less than W, then I need to see if I could include it partially or not. So I call the bound here, b dot bound. I call the bound function. If the bound is greater than the max profit, in that case, I in that case in that case I push this node for further consideration. Otherwise I don't include the current levels value. Yeah. In this case, I'm going to include the current levels value and check the possibility of having it. If it's not possible, then here I don't include it, and I calculate the bound without upper bound without including that value. If the upper bound is greater than max profit, in that case I push it to the queue for further consideration. So here bound. So here so here I just check if the current weight overcomes an upside capacity. In that case, I return 0. Here I have this variable, profit bound assigned to the value of the current profit. And here I'm gonna, in this case, I'm gonna add the item that that add the item that is one level above this, and I'm gonna check the index condition and knapsack condition here. If the value of k is not n, then I'm gonna include the last item partially, and then I return this profit bound. This was a bound function. So here we have the main function. Here I take the inputs and assign it to respective value, and here I call the knapsack function and I print the answer result. So that's all. Thank you.